All right, guys, we're going to talk about function notation today. If you guys could get out your Cornell notes and take notes as this video goes along, that would be great. Remember to get the title, the I can statement. Don't forget to put the date on the top right-hand corner of the page. Go ahead and pause the video and get that ready if you have not done so already. And also make sure that you guys are pausing this video when necessary. If I'm moving too fast, there's a pause button. Use the pause button if you need to. All right, so today we're talking about function notation. I want you guys to be able to use basically an equation as a function. The equations that we're used to right now have all been linear. So what we have here is a linear equation, y equals 2x plus 1. We could graph that as a slope of 2, a y-intercept of 1, and we would also be able to find out that it is a function. And if you remember talking about functions a while back, a function basically means that the x's don't repeat. The domain values don't repeat. If we had it on a graph, it passes the vertical line test. Well, if an equation is a function, then we can use function notation. This is what it looks like. We have f of x equals 2x plus 1. Basically, we're just going to be replacing the y with f of x. And we'll get to why function notation becomes important in mathematics here in just a minute. Let's see a worked out problem using function notation. This is function notation. You guys remember Charlie function here. This is Charlie. You guys remember Charlie from in class a couple months ago. Charlie basically takes a x value, and x value is an input, and it goes through Charlie, through the function, in this case 2x plus 1, and it comes out as a y value. But remember, we're replacing y with this new notation called f of x. So let me show you what's happening here. We have f of negative 2, because what we're saying here is that x equals negative 2. So we're going to be looking at f of negative 2. So that's going to equal 2x plus 1, where x is negative 2. 2 times negative 2 is negative 4, and negative 4 plus 1 is negative 3. So again, input negative 2 into our function, and it outputs the y value. Let's see that again with x equals negative 1. So this is going to be f of x equals 2 times x plus 1. Again, I'm getting 2x plus 1 from my function here, 2x plus 1. But this time, x is going to be negative 1. 2 times negative 1 is negative 2. Plus 1, negative 2 plus 1 is negative 1. So f of negative 1 equals negative 1. And we'll keep going here. This next one says, what happens if x is 0? What if the input is 0? The domain value is 0. What's the range value going to be? It's going to be f of 0 equals 2 times x plus 1, where x is 0. 2 times 0 is 0, and plus 1 gives us 1. So f of 0 equals 1. Let's try f of the next one, where x is 1. It's going to be f of 1 equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 gives us 3. So f of 1 equals 3. And lastly, for this one is going to be f of 2. What happens if x is 2? It's going to be 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So f of 2 equals 5. All right, the important part to remember here is the x-coordinate, or the domain value of a function, is called the input. And when we have an input value and it goes through our function, that's going to give us an output, the y-coordinate or the range of the function. Let's move on to our next example. All right, this one says pick 4 values for the domain and solve for the range. Remember that our domain is our x value over here, and it's asking me to solve for the range, the y value, or in this case, the f of x value. The function is x squared plus 3, and it's saying to pick 4 values. Now remember back when we were filling out tables before that we should choose a negative value, 0, and also a positive value. So I'm just going to choose -1, 0, 1, and 2. You can choose whatever number you would like. All right, for our first one, the question is, what happens when x is -1? Well, I'm going to substitute that into my function f of -1 instead of f of x. I'm going to replace my x with some parentheses. Got squared plus 3. Remember, when we're substituting, we should always use parentheses. And in this case, x is -1. -1 squared means -1 times -1. That's going to give us a positive 1 plus 3. And that gives us 1 plus 3, which is 4. So f of -1 is 4. Let's do that for 0 really quick. F of 0 equals 0 squared plus 3. 0 squared is just 0 times 0, which is 0, plus 3 is 3. F of 0 equals 3. And why don't you go ahead and pause the video and try f of 1 and f of 2 out. Again, you want to look for f of 1 and f of 2. Go ahead and give that a shot really quick. Pause the video and then come back to it and watch through and see if you did it right. All right, so let's see here. We're going to have, for f of 1, we're going to have a 1 in parentheses squared plus 3. 1 squared is 1 plus 3 gives us 4. So f of 1 equals 4. And then for f of 2, we're going to substitute in the 2. 2 squared is 2 times 2, which is 4, plus 3, which gives us 7. So f of 2 equals 7. Now you may have noticed that we do have a repeated y value. That's okay. That's still a function. It's only if we repeat the x values that it's not a function. This is a repeated y value, so we're still operating within a function. I've got 3 more problems for you to look at. I'm going to go one of these at a time. I'm going to ask you guys to pause the video and try it out to see how well you did. First thing I'd like you to do is solve for h of 3. Now this is what's beneficial about having function notation. This h tells me to look at a specific equation up here. It tells me to look at this one. Instead of saying what is y when x equals 3, it's saying what is h of 3. So they got 3 equations up there. If all of these said y equals, and y equals, I wouldn't know which one to use. But now I have a reference to the equation h. So we're going to use the function notation to use this function h. It says that h of x equals 5x minus x squared. Now we're going to substitute in for what x is. X in this case is h of 3. So we're going to write down h of 3 equals 5. And I'm replacing the x with 3, so I'm going to use parentheses. This is substitution. It should look something like that. 5 times 3 minus 3 squared. Let's take this one step at a time. H of 3 equals 5 times 3, which is 15, minus 3 squared is 3 times 3, so it's 9. So h of 3, 15 minus 9 is 6. So h of 3 equals 6. All right, let's try the next one. G of -1. G of -1. Why don't you go ahead and pause the video and give that one a shot. All right, let's try this one together. G of x equals 3 times x squared. And I put parentheses around x because I know that's what I'm going to substitute. Got G of -1 is what it's asking for, so we're going to replace that x with -1. Remember, exponents come before multiplication, so we'll leave the 3 out here. -1 times -1 is a positive 1. And 3 times 1 is a positive 3. So G of -1 equals 3. So hopefully you did that one okay. We got one more for you here. Go ahead and try out number 3 here, f of negative 5. Go ahead and pause the video and give that one a shot. All right, f of negative 5 tells me to use the function f. So f of x equals 3x plus 1. But this one's actually asking for f of negative 5. So guess what I'm going to replace this x with? I'm going to replace it with a negative 5. It's all substitution. F of negative 5 equals, what's 3 times negative 5 is a negative 15 plus 1 here. So f of negative 5 is negative 15 plus 1, which is negative 14. All right, hope that helps out with your exit ticket today. Do not forget to grab one from your teacher or whoever is there to give it to you. And make sure you turn that in before you leave. That is your ticket to leave class today. Have a good one, guys.